Lesson 19.2, Task 3. Use the standard normal distribution. The z-score in the number of standard deviations a given data value is from the mean of a data set. The z-score transforms any normal distribution to the standard normal distribution, which is a normal distribution with a mean of 0 and a standard deviation of 1. The formula z equals x minus your mean divided by your standard deviation transforms a given data value x to a z-score using the mean and standard deviation of the data set. Again, remember these are symbols that we have looked at in the previous task and symbols that you definitely need to be familiar with. Alright, the shaded region under the curve shown represents all data values whose z-score are less than 1.3. The standard normal table below shows the ratio of all data values less than a given z-score. The partially shaded column and row show that the data values less than a z-score of 1.3 include 0.9032 or about 90.32% of all data values in the probability distribution. Alright, so if we're using this standard normal distribution, you can see the z-score here. So we're talking about standard deviations. So we go +3 and we go -3 standard deviations, and this goes in decimals from 0 to 0.9. So this is your standard normal table for using your z-score. You can see that 1.3, they go to 1 and they go to 0.3, and that's where the 0.9032 comes from. So if you have this table, you could quickly determine that percentage. Alright, so it says a machine is manufacturing circular parts that cover openings on car engines. The mean radius of the cover is 2.5 centimeters and the standard deviation is 0.1 centimeter. Any part having a radius less than 2.18 centimeters must be rejected, and it will not sufficiently cover the opening. If the machine makes 340 parts per hour, how many parts will be rejected for being too small during an 8-hour period? Alright, so we're first going to use the formula to calculate the z-score for 2.18. Alright, so it says any part having a radius less than 2.18 must be rejected. So we want to find out what that percent is. So 2.18, so the z-score is going to be, that would be my x value, 2.18 is x, minus the average divided by the standard deviation. You can see this is given information here. The mean is 2.5, that's your average right here, and the standard deviation is 0.1, and that goes on the bottom. So when you calculate that, you get -3.2. If we come up here, -3.2 is going to be this answer right here. So it's going to be 0.0007, which as a percent would be 0.07%. Alright, so now it says use the standard normal table to find the ratio of all data values that have z-scores less than -3.2. Alright, so we just did that. So it says how will this ratio help find the number of parts that will be rejected as too small? So the ratio is the same as the probability that a part is rejected for being too small is what we're looking at. If the probability of any part being rejected is known, it can be used to determine the number of parts in a large sample that will be rejected. Alright, so it says from the table the ratio is 0.0007, which we've seen. Okay, all you have to do is look at the -3 and come over to the 0.2, and that gives you that decimal point right there. Alright, so again, you move it 2 decimal places, gives you the percent, so 0.07%. So if you know that 0.07% of all parts will be rejected for being too small, then you have to take the number of parts and multiply it by that percent. So how do we know how many parts? It says there's 340 parts per hour. how many would be rejected for 8 hours? So like one work day. So let's do 340. So 340 times 8-hour workday. So 2720 comes from multiplying the number of parts per hour times how many hours are in the day. So that's where that 2720 comes from. Multiply it by the ratio here, and that says 1.9. So if you round that up to a whole number, because you're talking about parts, you can't have a 0.9 of a part. So you're going to have about 2 parts rejected in that 1 day period. So in an 8-hour period, there will be 2 parts rejected for being too small. Why is 2720 used in the calculation above? It is in the table. Nope. The machine makes 340 parts per hour for 8 hours. So 340 times 8 equals that. That is true. All right, that's all for task 3. If you have any questions, let me know.